Okay, lesson 23, factoring polynomials. Okay, we need to go over a little bit of vocabulary first. A factor, okay, remembering what we do t-factor charts, and then you guys did like prime factorization. Okay, and prime is going to go into this again later, but factors of 18 would be like 9 and 2. Okay, and then it factors out even farther into 3 and 3 again. Okay, so that's a prime factorization, like that. And then there's a t-factor chart, which would be like 1 and 18, 2 and 9, 3 and 6. It just lists all of the factors in combination, okay? So when we start seeing polynomials being factored, we won't factor them this way, but remember the definition of factor. It's just two things that can be multiplied together to give you something else, okay? A prime polynomial is a polynomial that cannot be factored, okay? So we will get in more into that on the examples. And then the greatest common factor still applies here. If we can factor out a 3 out of each term, then our greatest common factor will be 3. Okay, so it's just like reducing, pretty much is what it amounts to. All right, so example 1. Start with this problem: 3x squared plus 6x minus 3. And we want to see if there's anything that we can pull out of each of these terms, okay? Remembering a term is separated by a plus or a minus, okay? So we have 3 terms. This is a trinomial with a squared, so it is a quadratic. And what is a common factor, our greatest common factor that can be pulled out of both of these? 3. So I can pull 3 out of here. And if I pull a 3 out of the first one, I end up with an x squared. If I pull a 3 out of the second term, I end up with a 2x. And out of the last term, I end up with a negative 1. Okay. The most common error I see here is people think that when they divide by 3, that it just magically disappears. So don't get too far ahead of yourself. Make sure that you keep that 1 in place. Okay. Works the same way with your x's and your x squareds. These are just coefficients of 1 up front, right? And that's it. That's all you can do. You just factor it out and rewrite it so that if you wanted to go back to this form, all you'd have to do is redistribute. So factoring is like undoing distribution. So that was example A. Example B, negative 4x to the third minus 10x. Now this one has a less common greatest common factor, but it does have a common factor. And I would advise you that if both or all the terms are negative, to pull out that negative. It will make your life easier in the end. Okay. So we have a negative 2. Is there any other common factors? X, right? There's an x in this one and an x in that one. Now, as an example, if this was x squared right here, my greatest common factor would have been negative 2x squared. Okay. I'll take the smallest 1. But since it's just x, we're negative 2x. Now we're going to rewrite this. I pull a negative 2x out of this one, and I end up with a positive 2x squared. Okay, it's like a division. It's almost like I'm dividing everything by negative 2x. Okay, so remembering that when dividing things by like bases, you subtract from their exponents. So there we go. That's positive. This next one's going to be positive as well because that negative also goes in there. End up with a 5, just 5, because we divided out the x's. Okay? Questions? Awesome. Go to that chart on page 164. Now, this is just some helpful kind of stuff. We've been doing factoring. It's the undo of FOIL is basically what that amounts to. Now these give you some examples. So that chart that we did a while back that said here's some helpful hints on easy ones to FOIL. This is a helpful hint on easy ones to unfoil. Okay, so as we go through these, I'm just going to point back to this chart, so I want to keep referring to it, so keep it handy. Example 2a, it says factor x squared minus 10x plus 25. Now we have the AC method, which most of you are familiar with. Maybe not you sophomores, but juniors should be familiar with it. But if there's not a different coefficient than 1 up front, we don't really need the AC method. We have to factor out the back part of it, right? So we factor out 25, and we find that the factors of 25 are 1 and 25, 5 and 5. Is there any others? Nada? So I've already factored out the back. I do what I know how to do first. I have to set up a pair of parentheses, right? Then I look at the back operator. It's positive, so I know what? My signs are going to be the same. I don't know if they're going to be positive or negative yet, but they're going to be the same. Okay, same sign sum, right? So they're going to be the same sign. They're either both negative or both positive. Then I look to the middle. Because it's negative here, what is my sign going to be? Negative. So both of them are going to be negative. Okay. Since my leading coefficient is just 1x, I can only put my x's up front. There's no other coefficient that goes with it. You can't put a 2 or anything out there. So I have my x's out front, and I have these two in the back. Since it was same sign sum, I need to figure out which of these add up to give me that middle term. 5 and 5. So there's really no question here. I ended up with something that looked like x minus 5 times x minus 5. Simplified, that would look like this, x minus 5 squared. Okay. So looking back up at your chart, okay, this is called the perfect square trinomial. Notice that if I look back here, this is a perfect square. If I look up front, that was a perfect square. 1 times 1 is 1. 5 times 5 is 25. And then since I know that my back piece is 5 and 5, the addition of those two gives me my middle. Okay, so we know that it's going to be a perfect square. And it's not something that you always notice right off the bat. But once you write down your answer, you should. And when you get to this point, make sure you write it down in your simplest form. Okay, questions there?
So the answer would be x minus 6 squared?
X minus 5. Yes, x minus 5 squared is what I would put for our answer. Okay, on B, it says factor this out. 4m squared plus 12mn plus 9n squared. Okay, remembering what I told you a little bit ago, there was a perfect square up front, there's a perfect square in the back. What do I start noticing here? Perfect squares, right? So hopefully, this one's an easy one that I can just do perfect squares in. So if I notice that right off the bat, I would try that first. And if it works, it works. If it doesn't work, then, well, I guess we go back to the drawing board. But there's a high probability that the perfect squares will work. So here we go. If this one's a perfect square, I'm going to put 2m in the front. The back is a perfect square, I'm going to put 3n in the back. Okay. Notice that when I multiply the backs, I get n and n. Okay, so n squared. Now, because this sign is positive, what do I know about my signs? They're going to be the same, and because that one's positive, I know it's going to be both positive. Right? Now I just need to check it. So 3n and 2m give me 6mn, and 2m and 3n give me another 6mn. When I add them together, I get 12mn, and looky there, it worked out. Okay, so that was nice. Questions there? Okay, those are just quick ways that hopefully, if it works out, that you can do one really fast. If it doesn't work out that way, then we'll have to do the AC method. Okay? We're here in a couple lessons, I think. Example 3. Factoring a difference of two squares. So this one, we'll notice again the same kind of concept that we did the last time. We'll notice a perfect square up front. 1 times 1, x, is going to be x squared. And in the back, we get 7 times 7, which is 49. So again, I set up my two parentheses. Okay, I'm going to expand this real quick so that you can see something. I have x squared plus 0x minus 49. So I expanded it into standard form with 0x in the middle. So I know that when I get my middle two terms, they're going to cancel out. Now, difference in two squares is nice because I noticed that right away. I have a perfect square up front, a perfect square in the back, and I look back here and I say I have a negative, so my signs are going to be different. And because my sign is positive in the middle, I'm going to go with the bigger number getting the positive. So the perfect square root of 49 is 7. So we'll put 7s in the back with my x's up front. And then I just check it. 7 times x is 7x. Negative 7 times x is negative 7x. When I add those two together, I get 0x. And it worked out perfect. So the difference of two squares, the quick way to see this, I have a perfect square up front, a perfect square in the back, and a negative or a minus in the middle. Okay? So a difference of two squares just shoots the first term right here and the last term right here, and then you make your signs opposite and you write them down. Questions there? Okay, I'm going to do one more that's kind of quick. If you see one that's got 4x squared minus 16y squared, okay, I have a perfect square in the front, a perfect square in the back, and a difference in the middle. So I put my two sets of parentheses. I do the perfect square up front, 2x. I do the perfect square in the back, 4y. And then I put opposite signs in the middle. And when I multiply these, I should get 8xy and negative 8xy up top. And then on the back sides, I get positive 8xy. And in the middle, they cancel out just like I thought they would. Okay? So we ought to be able to do these rather quickly without having to do a whole lot of work. That's the whole point of that shortcut. Okay, any questions now? No? All right, real quick property that y'all guys already know. I just need to remind you of it. It's called the zero product property. Okay, zero product property just says that if two numbers are multiplied together, a times b, and they equal 0, that one or the other has to be equal to 0 because they're multiplied by each other. So if two numbers are multiplied by each other and they equal 0, then either a or b must be equal to 0. So where this applies is if we broke something down, if we factored it, for example, if we had the one right before here, if it was x plus 7 multiplied by x minus 7, and that equaled 0, then either x plus 7 would have to equal 0, or x minus 7 would have to equal 0. And that'll help us later on because it'll give us one of our solutions. Okay? We'll do a few examples on that, and then we'll go over questions if you still have them. Okay, example 4. We're going to solve a basic quadratic. This is where we start seeing solutions. And most of you juniors will remember this from last year. So we have x squared plus 3x minus 10 equals 0. Okay, I don't have to use the AC method, that's nice, but I do have to factor out the back piece. So I'm going to factor out 10 really quickly. Oh, I'm sorry. Thank you. So I'm going to factor out 10 really quick. 1 and 10, 2 and 5. Is there anything else? No. Okay, so I'm going to do what I know to do first, set up my parentheses. Then I look at my back term. It's negative, so I'm going to have what kind of signs? Different signs, right? Because my middle one is positive, I'm going to put my larger number with it. Okay? Because I just have a 1x squared up front, I know that my x's are going to come up front. Because 10 factored out has to have a difference of 3, which one of these am I going to use? 2 and 5. Where does the 5 go? Goes up front with the positive. Okay, and then my 2 must be in the back. And then I want to check it really quick. 5 and x give me 5x. Negative 2 and x give me negative 2x. And when I add those two together, I get 3x positive, and it works out. Okay, so I checked it. It worked out really nicely. And we have to remember something. This equals 0. So there's one part of our answer. If we have an equal sign, I want an answer. Okay? If I have an equal sign, I want a solution. So using that zero product property, if I have x plus 5 and x minus 2, then one of these has to be equal to 0. One of them has to be equal to 0 because the answer or the product of the two is 0. So I'm going to let each of them equal 0 and then solve. So minus 5 from both sides, I end up with x equaling negative 5. Over here I'm going to add 2 to both sides, and I end up with x equaling positive 2. So these are my two solutions. Okay, x negative 5 and x equaling 2. Questions there? Nothing? All right. Moving on then. Last example, example 5. It says the application of the golden ratio rule, and this is actually applicable. There's entire documentaries on it. It's interesting. The golden ratio is approximately 1.6 to 1. It has been used by artists for centuries to create visually pleasing art. An artist wants to make a rectangular tapestry with an area of 90 square feet. So they drew it for us. That's nice. 90 square feet. Whose length and width are the ratio 1.6 to 1. What is the length and width that they should use? So remembering, they said a rectangular tapestry that should have the ratio of 1 to 1.6. Okay? So 1 to 1.6. And this was 90 feet squared in the middle. Okay. Anybody got a question as to why I set it up the way I did? Nothing? Okay. So, knowing this, I can start calculating some stuff. How do I find area of a rectangle? Length times width, base times height, all of those things are the same. Okay, so I have my height of x multiplied by my base of 1.6x, and that's going to end up equaling my area. What is my area? 90, right? So 1.6x times x is 1.6x what? Squared. Good. And that equals 90. I need to get x squared by itself. How am I going to do that? Say it louder. Divide. So 90 divided by 1.6 is what? 56.25? Okay, so now we have x squared equaling 56.25. How do I get rid of my x squared? I square root it. What I do to one side, I must do to the other. So the squared and the square root cancel each other out. So I'm left with just x now. And what is, we're going to have an approximation here, so let's write an approximation. So say that again. 7.5. Now, I want you to keep in mind what a square root means, okay? A square root is what multiplied by itself equals the number underneath it, right? So we have 7.5 approximately, but we also have a negative 7.5 because negative times a negative will also give us a positive, right? So a little side note, the square root of 49 then would be plus or minus 7, or that's positive or negative 7, right? Okay, we have to start thinking in those kinds of terms. So the square root of 16 would be positive or negative 4. Okay, so our answers are one of these two, and then we have to plug them in to check. And the answer is fairly obvious because we can't have a negative area when we end up multiplying these. We can't have a negative side length. We are going to definitely have to go with that positive one. So the answer is approximately 7.5 what? Feet, right? And that should be the answer for one side. Now I need to find the answer for the other side. We multiply 1.6 times 7.5, and what did we get? Approximately 12 again. Okay, so 12 feet, right? So there's my two answers, and we answered the whole question. Anything else? Okay, you got everything you need there.